All right, it's time for everybody's favorite thing, everybody's favorite word in geometry, proving. Oh, that means there's going to be proofs. So we got ways to prove triangles similar. We finna gonna do some proofs. Woo! So something to remember about proving triangles similar. We know that in order for figures to be similar, they have to be the same shape, but not necessarily the same size. So their angles have to be congruent, but their sides need to be proportional, right? The sides are proportional. They could be congruent sides, but they at least have to be proportional. The angles will have to be congruent. The most common one we're going to use is this first one here, angle-angle similarity. All right. There's also side-side-side similarity, where we show all the sides are proportional, and also side-angle-side similarity, where we show the two sides are proportional, and the included angle pairs are congruent. Okay. But the most common one will be that angle-angle similarity. So let's hop to it here, shall we? We've got angle 1 is congruent to angle 2, and I want to prove that AEC, triangle AEC, is similar to triangle ADB. I'm going to go ahead and outline those two triangles because it's overlapping and wonderfully confusing here. Okay. All right. And then I've also got ADB. And why don't we go ahead and pop in the lovely purple marker, because that was fun. Ooh, that's wonderful. All right. Cool. So I got to prove these two triangles congruent. Well, I know angle 1 is congruent to angle DOS. What else do I need? Well, like I said, the most common one we use is angle-angle similarity. We can abbreviate it like that. Are there any other angle pairs that are congruent here? We'll chickadee check out right up top. Woo woo! And I'm going to then slash it with a green because I'm crazy like that. Those two angles are congruent to each other because they are the same angle. Reflexive property, go and do that. Do I have enough information to prove these triangles similar? I sure as heck do. Let's jot it up, write it down. Bibbidi bop, just don't stop. All right, so I already had angle 1 congruent to angle 2, so I just need to say that angle A is congruent to angle A. And I can say it with just angle A because there's no other angle with that vertex. And that was reflexive property, something we usually use just for sides, but it can be used for angles. It just doesn't happen as often. All right, so do I have these triangles similar? I do. AEC is similar to triangle ADB. Awesome. All right, we will go further than just proving triangles similar in the future, much like we did with proving triangles congruent. We went on to things like CPCTC and beyond. Same kind of deal will happen here in the coming lessons. All right, that's some fun stuff right there. You know, Jenny's loving this as well. She's learning how to prove triangles similar, even though she's just a dog. Check it out. I don't know how she's falling asleep here. She's got her calculator and everything, but apparently this is not entertaining to Jenny. Hopefully it is, however, entertaining to you. All right, back to the math. All right, last problem of the video here. A little quicker than the last one. I do apologize for the length of the other one, but anyways. Let's do this. We've got parallelogram, ABCD, and we want to prove triangle BFE is similar to triangle CFD. I'm thinking we might want to outline those. We've got BFE, and we've got CFD. Now I want to prove those two to be similar. Sounds wonderful. Well, what do I know about parallelograms? I get congruent sides, get parallel lines. Ooh, what do I know about parallel lines? What do I get from those? From those, I get angles, right? And when I'm proving similar polygons, proving similar triangles, mainly in our forte here will be proving triangles similar. I'm going to be using angle-angle similarity and be focusing on angles. I told you that right off the bat, right? Okay, that's a lovely little hint from Mr. Allen. So what do I need to prove parallel? What can I get from this? There's a couple ways of doing this proof. And a lot of us might jump right to these two being congruent because they're vertical angles, and you are not wrong. All right? However, if I were to prove this line parallel to this line, then use this as a transversal, these angles, this one and this one, would be congruent. And I'd also have, when drawing this as my transversal, I'd have this angle congruent to this angle. For the same reason, alternate interior angles. And you know what that's going to do? That's going to save me a whole step. Woo woo! Again, vertical angles congruent would not be wrong, but I'm going to save myself a step. I've got two pairs of angles congruent. I've got angle-angle similarity. We're ready to rock and roll. Let's write this bad boy up. All right. So, I'm going to first say that DC is parallel to BE. If it's a parallelogram, then opposite sides parallel, which is technically the definition of a parallelogram. All right, but I like to write it as an if-then statement. Let's write up some angles. So I've got angle. I'm just going to go ahead and jot some numbers down. It's a little hard to write them down in there, so I'm just going to jot them down up here. We'll say this is angle 1, this is angle 2, this is angle 3, and this will be angle 4 over here, okay? So those are going to be my angles that we're referencing. So I've got angle 1 is congruent to angle 4. And I've got angle 2 is congruent to angle 3. Just want to save some time there, but I didn't want, it's hard to write very small in the iPad. All right, and that is by if parallel lines, then alternate interior angles are congruent, right? When you look at it with the different transversals, there are still their alternate interior angles based off of the parallel lines and the transversals we're looking at. And since I've got two pairs of angles congruent, I've got triangle BFE is similar to triangle CFD by angle similarity. Woo! Woo, woo, woo! That's how you're going to do it. We're going to expand on this in the next video, which I know you're excited about.